Good morning, Year 10. Just a last bit for me really over the summer. I've just done a quick review of all of our LPs throughout this year. I'm going to focus on LP1 this time. Can I just request, please, that before you begin our video, I want you to go and watch the Foundation LP1 review. The reason for that is the fact that obviously within our knowledge organisers, we've only had the additional higher content. We haven't had all of the foundation skills on there due to the fact that obviously you are hitting for the higher bracket, but that doesn't mean that you don't need it. So what I want you to do is I want you to go onto the foundation. I want you to go through all of her, Miss Clark's video for LP1, watch that in detail, make any notes of stuff that you're struggling with so that when you come back in September, we can assess those misconceptions really and clear them up before we begin. But then come back to my video and watch the higher content only, okay? Because this will just be a review of the higher content. So, just to be able to go through, to begin with, your GCSE, you know this really already, a lot of it. There's various, if you look here, there's various aspects within your exam content, okay? And there's two tiers, you know that you're doing higher. Foundation is still really key. You've still got all the information in there that you need to be able to do. All of you guys at the moment are put in for be doing the higher for paper. We will be reassessing that. We do every year, and obviously we'll make have an idea about where you're going to end up before you sit your paper. You'll have 3 papers. Paper 1 will be non-calculator. Paper 2 and 3 are both calculator papers. Okay, every paper is an hour and a half, and each paper is out of 80, so therefore 240 throughout the whole exam. Okay, so when we're talking about 240 throughout the whole exam, everyone always says what's the percentage or what's the pass rate, and we can't say that at the moment. Okay, there is not enough information of that at the moment. We have our ideas of predictions as to when you do mocks. We use the previous grade boundaries, and I'll go through those further with you in September, October, November. But right now, we need to focus on being able to cover as much content as we can before we begin anything else. Within the papers, generally speaking, we start off easier, and then throughout the paper it gets harder. So therefore, there's the range of questioning. Now, when we say that, although it does technically get harder throughout the paper, obviously there'll be some aspects within math that you're more confident with than others. Now, if they're at the end of the paper, it might be that you can access those questions before doing the others. So when we do a paper, my main thing about doing papers is making sure that we don't just stop and say, well, I can't do these last 3 questions, therefore I can't do any more. You really need to push through and try absolutely all of them, okay? When we do exams, there's 2 assessments technically available. You've got June and November. Obviously, the aim is that you'll all sit it in June. We don't want to have to do any resits at all. And then, obviously, you'll be graded from 1 to 9, okay? In the higher paper, you can only get a grade 4 to 9. There is technically a grade 3 available, so you can get that. It's just, it's kind of a very small grade boundary area. It's just for those people who've just missed out on the 4, really. So they don't end up with an ungraded, which means you get no grade for your exam. So there is a grade 3 for those students, but generally speaking, we want to be, especially within the higher, we want to be above a 5, because otherwise the foundation paper's there as well. So we want to be aiming for kind of a 6, 7, 8, 9. Within our paper, within the higher paper, it's all split up into these 5 areas. You can see the percentages, what we call percentage weighting for the exams, and that basically means that you can see that the majority of your paper in comparison to anything else individually is based on algebra. That's because there's an awful lot of questions that, even though they might be shape or they might be number, they've got algebra within them, okay? Even proportion and all of those, they've got an algebra link sometimes, so therefore that's why that generally has a higher weighting. But you will also see that there's a lot of others. The lower actual rate weighting, which is always surprising for people, is number. Even though it's kind of your main area, it's a lower weighting for pure number questions, and obviously a lower statistics and probability. And that's why when you look next year and this year at our overall scheme of work, you'll notice that these 3 areas are the areas that heavily covered over this year. Okay, again, this, you can read this. If you want to pause it and have a full read of it, please do. This just gives you an idea really of how you get the questions. These are the styles of questions. We call them AO1, AO2 and AO3. So AO1 is your standard technique. That's just being able to answer a question or recall a simple fact, okay? Reasoning and interpretation is AO2. That's things like, as it says, making decisions, using reasoning, presenting an argument or a proof of something, okay? And then you've got AO3, which is, as the other part, which is solving maths within other contexts. So that's things like, we always talk about Pythagoras. An AO1 Pythagoras question would be, here is a triangle, a right angle triangle, calculate the missing length. And therefore you'd use Pythagoras to find the missing length. An AO3 version of that question would be, there's a ladder leaning against the wall. The ladder is 2 meters away from the base of the wall on the floor, on the ground. The ladder is 5 meters long. How high up will the ladder reach against the wall? Questions like that would be an AO3 because it's a Pythagoras question, but it's in a different context. It's in a real life situation. Okay? So we're going to start off with our first organizer, or first knowledge organizer. So we are looking at various aspects within this. So we're looking at Pythagoras, we're looking at plotting quadratics, estimating the mean, mixed numbers, adding, taking away, multiplying and dividing those, and then constructing accurate triangles. Each of these, okay, there's 5 areas. We have obviously covered much more than 5 areas in the first term, okay, in the first learning program. We covered many more topics than that, but these are the ones that are additional to the foundation content that others have sat. So that's why I'm saying it's so crucial that you go through the foundation overview first and then do this one, because this only tops up what the foundation group have been doing, okay? So first of all, Pythagoras. You did Pythagoras a little bit in year 9. Most of you will have looked at it at some point. But obviously, moving on, as I said before, this kind of, moving on to your AO3 and AO2 type questions, would this ladder be appropriate for this job if it's this long? That type of idea is your AO2. It's your reasoning, give a reason why this might happen. But each of these style questions are your AO3. Okay, generally speaking now, Pythagoras doesn't tend to be given as an AO1, doesn't tend to be given as a, here's a right angle triangle, calculate the missing length, okay? Sometimes it can be basic skill by giving you 2 triangles attached to each other, so you'll have to use Pythagoras twice, okay? But that's kind of like the basic side of Pythagoras for that. AO2 and AO3 are more challenging in the sense of you may have to develop the triangle yourself before you can even begin the question. You're looking at how that triangle sits as well, okay? So, if you want to give these a pause, give these questions a quick go on here, okay, and see what you get, and you can email them into me. You've all got your email address by now. Email your answers into me and I can double check them for you if you want me to, okay? So you can give those a quick go if you want. So, next 2 parts, plotting quadratic graphs. Now, we looked at this a lot this year, a lot. And we looked at what we can identify from it, how it looks, okay? And we've referred to the word parabola. A parabola is just the shape that this graph creates, okay? If it is an upward parabola, so we call them a smiley face as well sometimes, if it's an upward one, then it's a positive x squared value, okay? So the coefficient of the x squared is a positive. If it's a negative coefficient of x squared, we get an upside down parabola. We get an upside down smiley face, an unhappy face, okay? So this one here, the a value, the coefficient of the x squared would be negative, okay? This one here would be positive. If you remember as well, we talked about this c value on the end being what's called the constant. That would be the value where it crosses the y-axis, okay? So when this equals 0, we get this c on the end will be where it crosses this y-axis. So say your curve crossed here, then it would be this value here would be our value c, okay? So we did a lot on that. Go back through your book and you can have a little look through it. We then talked about fractions. Now, as I said, the foundation group looked a lot at multiplying, dividing, adding and subtracting fractions. We didn't base on that to begin with. We went straight into looking at mixed numbers and improper fractions. we looked at the fact that when we add or subtract with mixed numbers, okay, we need to think about what that means. So when we're adding them, we need to think about converting the denominator to a common denominator, okay? And therefore we need to use equivalent fractions to do that, because we need to keep the fraction meaning the same, just with different numbers, so that we can do our calculation, okay? Same with take away. We also looked at if you can't take away those numbers, we end up with a negative, or if we can't take away the fractions, we end up with a negative bit of fraction, which means you'd have to reduce the whole. Okay, I hope you remember that, doing that bit. If you end up with a top heavy fraction when we had to increase the whole to kind of counteract that. The next two parts, when we looked at multiplying and dividing with mixed numbers, the most crucial part of this is always ensuring that before you begin any part of multiplication or division, we convert them into improper fractions. So they've got to be kind of ordinary fractions. They've got to be plain fractions. They can't have a mixed number involved, because if they have mixed number involved, we can't do our multiplication. So we converted them each to, if you look at this one here, converted them each into an improper, so 7/3 and 9/2. And then at this point, there's two options. Either you multiply straight across, so 7 times 9 and 3 times 2. Or, and then you simplify it down, that's one way. Or you do your simplification first, which is what we started to look at, because we wanted to ensure we could do this and then build it with algebraic fractions. So we looked at saying, well, if we've got a 3 on the denominator here and a 9 on the numerator here, we can cancel these out and divide them both by 3. So therefore, we're multiplying by 3 times less, and we're multiplying the bottom by 3 times less. Okay, so therefore we divide that by 3, divide that by 3, then multiply 3 by the 7, 7 by the 3 to get 21. 1 times the 2, get the 2. Turning that into a mixed, 2s into 21 go 10 times with a remainder 1. Okay, exactly the same with the division. Okay, apologies, that should be a division symbol there. It seems to have kind of paused for a minute. So we look at converting them each to an improper. And if you remember, when we're doing division, we keep the first fraction the same. We do the inverse function. So instead of divide, we multiply. And then we do what's called the inverse of that fraction, which is called the reciprocal of that fraction. So instead of it being 11/3, it'd be 3/11. And now we just multiply again. 9 times 3, 4 times 11. And if we could simplify that down, or if it was improper, we would deal with that again. Okay? Okay, again, estimating the mean. So when we look at estimating the mean, the mean is obviously the value when we share equally a certain amount. So if we put it in kind of real life context, if you and 4 friends, so there's 5 of you, each had some money, and you were trying to work out your mean average, what you would have to do is you would all add your money together into one pile, and then you would split it amongst each of you equally. So you'd all put in however much you had, and then you would divide that amount by the 5 people to get an even spread of how much it would be. Okay, it's the most common used average for everything. So generally speaking, when you hear about things on the news, or when scientists use things, when they talk about the average, they quite often mean the mean average, even though they don't say mean. Okay, and that's because the assumption that you make is that it's the mean average. So when we talk about that, we're talking about the sharing equally of an amount, even though everyone might have a slightly different amount. If we talk about the mean average speaking, we have this amount between us. Okay, so the estimating the mean is the same process. It's just that we don't know how many each people have. So if we talk about you and your friends with money, it might be that you don't know how much each of you have exactly. It might be that one of you has between £0 and £5, one of you has between £5 and £10, 2 other people have between £10 and £15, and the other person has between 15 and 20. So you don't know how much they have, but you know it's between that bracket. Therefore, what we do is, instead of adding all the money together, we can't do that. I can't say, well, I'm going to add your money, which is somewhere between 0 and 5, to their money, which is somewhere between 5 and 10. We actually take an estimation for the amount for each of them. So we make the estimation, we make the assumption that the person who has between £0 and £5 has £2.50 because it's in the middle of their range. We assume that the people who have between 5 and 10 actually have £7.50. And the people who have between 10 and 15 have £12.50. The people who have between 15 and 20 have £17.50. So we just make the assumption that they each have the middle value of their range, and then we add it all together, and then we share it out evenly. Okay, so that's how an estimated mean works. So if we look at this question is referring to the amount of cappuccinos that people have been drinking. So this is the amount of cappuccinos they have over a period of a week. This is the number of people who said that value. Okay, there was 18 people in total, or sorry, per hour. So this is the amount of cappuccinos made per hour. So in total was 18. So when we look at that and we say, well, actually, twice there was between 0 and 3 made. Well, 0 and 3, we can't work with that. So what we do is we take the middle value, which gives us 1.5, and then we say, right, 2 lots of 1.5. Okay. We then look at 4 and 7, the middle value, 3 lots of that. 8 lots of the middle value, 3 lots of the middle value, 2 lots of middle value. Then we add all of these together. Okay, because that gives us our estimation for the total amount made. Okay, again, it's not exact, it's always an estimation because we are working with values we don't know definitively. It's always what we call grouped data. Okay, so when we've got our total estimated amount, we then divide it by the amount that's given to us. Okay, and then we would get our answer. And in this case, it rounds to 10 per hour. Okay, if we get a decimal here, we can leave it as a decimal unless it's talking about something to do with people or cappuccinos made or something like that. If it's talking about money, you can leave it as a decimal. We don't have to round just because it's an estimation. Our estimation comes from the top area where we estimate them having the middle value. The final bit, in addition to all the foundation, which obviously you're looking at as well, the final bit we've got is talk about constructing triangles. Now, the most important word I can refer to here is accurately, and using an accurate diagram. So many people say to me when they come to construct triangles, well, I can draw that, look, and they draw it and it's roughly right. Well, roughly right doesn't work in your exam. And actually, even if you get it exactly right in your exam, but you have no lines to show how you've done it, you still won't get full marks. And I think that is one of the most crucial things to get through to people, really, is you must show your construction lines. If you don't show your construction lines for constructing triangles, for being able to bisect an angle, to be able to perpendicular bisect, to be able to do loci, all of these things, if there are no working out shown, you will not get the mark. So you must be able to show these little pink curves. Can you see here, they're all highlighted in pink. Those pink curves are actually what gets me the mark, not the triangle itself. Okay, the triangle itself will be worth 1 at the end just to show that it all matches up. But actually speaking, it's those curves that finish off all the other marks I'm going to get. Okay, it's really important that you do know that and you do make sure you focus on that and being able to do it. So that gives you all of your LP1 coverage. Now, obviously, you need to make sure that you've done your foundation LP1 as well, because that is all the individual bits that I've not covered. Okay, your scheme of work, just grab it off the wall actually, your scheme of work is huge. Okay, and this is accessible somewhere online. This has every single topic you've covered. Now, there's no way, if you look at where LP1 is there's no way I've covered all of that. Okay, these top 2 bit sections here, but I have covered the areas that you wouldn't be covering within foundation. So therefore, you still need to do that foundation work. Okay, so please make sure you have done that as well. Right, I will say cheerio, and I will see you whenever you watch LP2. Okay, again, LP2, please watch the foundation LP2 first, then come back to me. Okay, bye everyone.